morning. I am SWAROOPA, working as a assistant professor in CST department from Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss about DA subject, design and analysis of algorithms. See, the design and analysis of algorithms. The syllabus for the basically it's all about the course objectives here. In the course objectives, the students will try to learn about the asymptotic notations like big O, big omega, and big theta, and various algorithms, and how we are designing the algorithms in each and every method, and we are calculating the time complexity, the space complexity, and there are the certain concepts in the dynamic programming in the greedy method. By using the greedy method in the dynamic programming, there are several applications are there. And the next about the knapsack problem and the job sequencing with the deadlines, and next about the backtracking. These are about the COs in the DA subject. And the next one is course outcomes. What you are getting what you are getting from through this syllabus. See, basically in the course outcomes, it's all about it's divide and conquer strategy and various greedy algorithms and design algorithms using dynamic programming, and there will be NP hard and P hard. By through all this, we are getting the knowledge about this course. Okay, these are the 4 steps. And the next one is the syllabus. The syllabus of this DAI. The first unit we are going to understand about the algorithms, performance analysis, space complexity, time complexity. Here, what do you mean by time complexity is nothing but the minimum amount of the time required to execute a certain problem is nothing but the time complexity. Space is nothing but the minimum amount of space is required to generate a particular algorithm is nothing but a space complexity. And we are knowing about the asymptotic notations like big O, big omega, and big theta. And there will be a various disjoint sets, and we are going to find out the find operation and the union operation in the first unit. And the next unit, it's all about the divide and conquer strategy. The divide and conquer strategy, there are the various methods are there in this. Various methods are there, and there in the divide and conquer there will be this applications also. Applications are also we are going to study about this binary search, quick sort, merge sort, and Strass and matrix multiplication. See, for all these methods, we are again going to calculate the time complexity, the space complexity for these applications. The next one, third unit, it's all about the greedy method. In the greedy method, these are the applications like knapsack problem, job sequencing with a deadline, minimum cost spanning tree, single sort shortest path. Okay, and the next it's coming to dynamic programming. There will be all pair shortest path and optimal binary search tree. Okay, and the next in the module 4, that is dynamic programming. In the dynamic programming, there will be a 0/1 knapsack problem, reliability design, a traveling salesman problem, and again in the backtracking there will be various applications like n-queens, sum of subsets, graph coloring, and Hamiltonian's cycle. Yeah, these are all about the 4th unit. And the next 5th unit is about the branch and bound general method like 0/1 knapsack problem, LC branch and bound, FIFO branch and bound, traveling salesman problem. And here the last, it's all about the some theory will be there in NP hard and NP complete solution. This we are going to read about in the branch and bound solutions. Now let us come to the topic about the divide and the conquer methods. See, divide and the conquer is nothing but basically there will be a large program will be there. This large program is divided into the into simple sub problems. Okay, this large problem is divided into the simple sub problems. Okay, this sub problems again we are going to work it out. And basically there will be a large program. This large program is divided into the simple sub problems, and this sub problems we are going to deal about. In this divide and conquer, there are the in the divide and conquer method there are the certain applications are there. First one is binary search, and the next one is quick sort, and the next one is merge sort, and the next one stratus matrix multiplications. Okay, these are all applications that we are going to read about in the divide and conquer strategies. First we will see about this binary search. Okay, we are going to learn now. Here is binary search. In this binary search, suppose if we consider the example for the binary search, this will be first of all we have to write down in the this format. After that, what we have to do means we have to mark it into the index form. We have to mark it out down. Okay, first these are the elements in the array. Okay, these are the elements that we are arranged in the array. After arranging the elements in the array, the next step is we have to mark it as the index form, like 0 1 2 3 4 5 6 7 8 9. Okay, first we have to initialize this elements in the array. After that, we have to mark according to the index. After marking this index, now we have to find out the key element from this. What the element we have to find it out? 59 we should find it out. See, generally if there are 10 elements, it is easier to find out the 59 element. Okay, suppose in the array there are 100 number of elements. How can you are going to find out? For that purpose we are using this divide and conquer strategies. The large problem is divided into the sub problems, and then we are going to calculate it. Okay, this is large. Generally I have taken the simple problem. That is nothing but I have taken the 10 elements. The 10 elements are kept into the one array, and we are going to find out this 59 element. First, what we have to know, what we have to find in this particular array, 59th element we have to find. We have to find the 59th element. How we are going to find it out? First, we have to calculate the mid. Okay, we have to calculate this elements in the mid. How we are going to calculate? We are taking the first index and the next the last index by 2. That is 9 by 2. That is equals to 4. Now, what is the mid element? Now, mid is equals to 25. Okay, mid is equals to 25. Now, we have to check these three conditions. See, if we have to find out this particular element unless we are getting the key is equal to mid. If 59 is equal to 59, 59 is equal to 59, we are getting the result and don't do any other process. If it is greater than or less than, we have to calculate it. See, now what is the key element here? Key element is equals to 59. What is the mid element here? 25. Now what you have to do means you have to check the condition. What is the first condition here? If key is greater than mid, then start is equal to mid plus 1. What is the key here? 59. Okay, what is the mid value here? Mid value is nothing but 25. Okay, 25. See, when you are checking the first condition, if the key is not equal to mid, then we are going to check a second condition. That is, key is greater than mid. Yes, key is greater than mid. Then what you have to do? Then you have to perform start is equal to mid plus 1. Okay, start is equal to mid plus 1. What is the mid value here? 4. Okay, that is 4 plus 1. That is equals to 5. Okay, now start is equals to 5. Okay, from the start element of 5, we have to take up to the end element is 9. So from this large problem again is divided into the sub problems. That is 45, 59, 63, 71, 89. Okay, now we should take it as a 5, 6, 7, 8, 9. Okay, after taking means the large problem is divided into sub problems. Again is divided into 5, 6, 7, 8, 10. Again you have to calculate the mid value here. How we are going to calculate the mid value? Mid value is equal to m is equal to 5 plus 9 by 2. That is equals to 14 by 2. That is equals to 7. Okay, mid value is equal to 7. Now here what is the mid value here? 7 is equals to mid value is equals to 63. Now here mid value is equal to 63, and what is the key value here? 59. Now again you have to check the condition here. How we are going to check the condition here? See, if key is greater than mid, no, key is not greater than mid. Now we have to check for the key is less than mid. That is 59 is less than 63. Now what you are getting here? End is equal to mid plus 1. What is the mid value here? What is the mid value here? 63. Okay, that is equals to what you get here? 7. So 7 plus 1, that is equals to 8. Okay, now end value is equals to 8. Okay, now again you have to now what is the mid value here? End value is equals to mid value is equal to end is equal to 8 plus 1. Now we have to take it up to mid here end value is equal to mid minus 1. So end value is equal to mid minus 1. Now here what you will get here? 7 minus 1. What do you mean? 7 minus 1 means what you are getting here? That is 6. That is 7 minus 1 is equals to 6. Now end is equals to 6 here. Okay, now what is the start here? Start position is equal to 45 and end position is equals to 59. Okay, now what are the here index values? 5 and 6. Now again you have to calculate the mid value here. How we are going to calculate the mid value? Mid is equals to 5 plus 6 by 2, that is equals to 11 by 2, that is equals to 5. Okay, now what is the mid value here? 5 means 45. Okay, 5 means 45. Now again you have to check the condition. What is the key value here? What is the key value? 59. Now we have to check 59 is greater than 45. Okay, 59 is greater than 45. Now 59 is greater than 45. Then what you will get here? Start is equal to mid plus 1. What is the mid value here? 5 plus 1. What is the value here? 6 you will get. So what is the key value here? 6. Now again you have to calculate here 59, start is equal to 6 and end is equal to 6. Now again here mid value is equal to 6 plus 6 by 2, that is equals to 12 by 2, that is equals to 6. Now what is the key value here? What is the 6 value? What is the index value? 6 value here? 59. Now what is the key value here? 59. So 59 is equals to 59. Okay, this you are going to how the calculate the key value through the binary search element. In this starting we should take the array element. In that array element again you have to calculate the mid value. After calculating the mid value you have to check these conditions. Okay, if key is greater than mid, start is equal to mid plus 1. If key is less than mid, end is equal to mid minus 1. From these steps, again you have to divide into the sub problems, and again you have to calculate the mid. Again you have to check the condition, and again if it is mid plus 1 or mid minus 1, you have to do it. And at the last you are getting the result up to until and unless you have to key is equal to mid. Up to that you have to find out this all the elements. Okay, this is how we are going to calculate the binary search in the divide and conquer strategy. This is a one more simple technique to calculate. Whenever the large problem is there, we are going to calculate into the small problems. Okay, thank you.